Thank you, everybody, and good morning, everybody. Welcome to the seminar on cellular vehicle to anything, or we call as CV2X. I'm Subhanshu Saw, Manager Solution Engineering at Andretsu. Thank you for joining this webinar, and let's explore how CV2X is shaping the future of intelligence transport. Here is what we'll be covering today, starting with the basics of CV2X, its evolution, technology stacks, use case, and what is the difference between CV2X and DSRC? Well, then we'll move on to the challenges, the testing needs, and conclude with a look into the future. Let's start. So here is the overall picture of what CV2X looks in a real life scenario. So we have the PC5 communication, what we call as the side link, where the vehicle communicate two vehicles communicate or multiple vehicles communicate to each other directly. Then we have V2N. So V2N is vehicle to network. So it can be any network like LTE, 5G. And we have the services which supports this overall network. These side links can be either to any vehicle or to any pedestrian, to any infrastructure. It can be anything. That's why we call as V2X or cellular V2X. So what is this V2X? So it comprises of two technology. That is the PC5 communication and the cellular technology. So this cellular technology, when we come to cellular, first it is the LTE V2X, which is defined by 3GPP release 14. And moving on, as the new technology evolved, like the 5G, so this L2 or the NR-V2X is defined in release 16 and release 17. So both this technology, PC5 and the UU communication or the network-based communication comprise the overall CV2X. So how these two are different, the PC5 and the UU communication. So PC5 communication is a direct communication between vehicles or any infrastructure or any pedestrian or anything around the vehicle. And when it comes to a cellular, where it has to communicate over to a far distance network, it has to communicate via UU communication or the cellular network, which can comprise of LTE or maybe the 5G technology. So when it evolved, so initially it started around 2018. And initially it was used, initially all the operator, all the vehicle manufacturer used DSRC. So due to some limitation on the DSRC, they started gradually moving to the cellular based technology. And other the other regions like China, US, UK, they adopted CV2X as their standard due to the limitation of DSRC. And gradually it progressed to, and it is progressing to 5G technology also. So this is the overall roadmap or the evolution of CV2X technology. So when we are talking what is the limitation of DSRC or CV2X? So basically DSRC was a short range, or we call as the direct short range communication. So due to the limitation, why? Because it is very short range. And there is a latency, there is a very high latency when they are communicating, when the network is communicating between two vehicles. So due to this limitation, we adopted CV2X, which is 3GPP defined. It has a longer range and it is keep on evolving, like from LTE to 5G, it is keep on evolving. So that's why DSRC was removed and we adopted CV2X. So when we come to the technology stack of CV2X, so obviously when we are talking about cellular base, so cellular will be driven by the 3GPP spec, which defines all the low layer protocols like the 5-layer MAC, RLC, PDCPU, and in the top of that layer we have the PC5 communication also, which is which is governing the PC5 communication, and the lower part will be governing your cellular based technology. So this both the PC5 and the cellular are defined by 3GPP on the 3G. If you go to the 3GPP spec, you'll find the 3GPP for 5G as well as for the protocol stack. And for the each layer also, we have the predefined protocols, how it has to be governed, and uh, um, and it has to be implemented. So combining both these things to a integrated to a system, it works as a CV2X technology. So here are some of the use case where we can use the CV2X technology. First is the collision avoidance. Then we have the traffic light.
We can hear you, sir. Can hear you.
Yeah. And we have the pedestrian warning. Then we have the SD map updates and the platooning corporate driving. So what is this platooning corporate driving is? Like it is a group of vehicle traveling together in a coordinated with a very short interval of distance or very short interval of time. So this has to be coordinated when you are driving in a highway, or if a long queue of vehicles are there. So each vehicle has to communicate with each other so that they should maintain a proper channel or proper lane so that collision can be avoided. So these are few of the use case what I have defined, but there are multiple use case, and in the evolution of time, new use case are coming up, which makes driving experience much better. And one of the key feature of that is the autonomous driving. So that is the future what we are looking, autonomous driving, and we have vehicle safety. Everything comes into picture when we implement CV2X. So going future, we have coming up are the NR-V2X. So the major difference between having LT V2X and NR V2X due to the latency. So when you come to LT VTX, that is when the vehicle communicate or the data is exchanged between the vehicles, the latency is calculated by 20 to 30 milliseconds. But when we implement NR V2X, this latency drastically reduce less than 10 milliseconds. That's why most of the operator or the vehicle are going forward and implementing NR V2X. So when it comes to challenges, like how we are going to implement or what will be the effect when we implement there are some of the challenges. What is that? Interoperability among OEMs and vendors, and regular approvals across different countries. Regulation, because we need to get approval from different countries, need rigorous testing with different conditions, and the module should be coexistence with the legacy network and the 5G system. Legacy network can be either 2G, 3G, and the future technology, the 5G. And going forward, we may have different technologies coming up that has to be implemented or that need to be tested so that they can operate in any environment. And the last and not the least is the deployment cost and the security. So these are some of the challenges which operators plus the vehicle manufacturers uh, comes into picture. Okay. To overcome these challenges, yes, we need to do lab testing. Rigorous lab testing has to be done for each and every module. After we have done the rigorous lab testing, this has to be deployed in the field and need to be tested. So key feature to be tested are the latency, how fast we can transmit the data and how fast we receive the data, that need to be tested. The range, obviously, that is the crucial things, how far we can reach and how fast we can reach the data. And it should be reliable. The data what we are transmitting should be reliable. To test all this feature, yes, test vendors like Anretsu comes into picture, and we have the solution where you can use this solution for your testing purpose and provide that results to your vendors and implement that into your vehicles. So now concluding on that this part and looking future, yes, CV2 is crucial in future in intelligence transportation. So it offer, why we use this one, it offer ranges, reliable, flexible over DSRC, and collaboration with telecom operators. Then we have automotive and government is the key. And if you are looking the future is the autonomous driving. That is one key feature, safety of the vehicle, of the passengers, and smart mobility. And the key feature is that it should be seamlessly integrated with different technologies. So this is some of the key highlights of CV2X. And now I am going to hand over to Namita, who will be giving the idea of how Andritsu is implementing this technology, or how you are going to help. Andritsu is going to help you in testing this CV2X technologies. Yeah.
Yeah. Thank you, Sahu. That was a great insight into the technical aspects of the CV2X technology. So good morning, everybody. I am Namita, and my side of the presentation today is going to be just to briefly touch upon how Andritsu can help you with the testing of CV2X technology, especially if you are designing a module which has CV2X in it, or it has a TCU related technologies in it. So how can we go about with testing it, right? So I'm going to be focusing very specifically on CV2X, that is the 3GPP based LTE CV2X or PC5 communication that we call it. The kind of diagram that we have on the screen or on the slide is a typical CV2X scenario, I would say, or mostly I would say a vehicle-to-vehicle communication, right? So on the left-hand diagram that you can see, over here you have one vehicle talking to another vehicle, which is a PC5, and the communication that we use is PC5, right? So this is the one that is defined in 3GPP, and we also call it as LTE side link. So like your typical cellular communication, there is no, usually we have a base station, you'll be interacting with the base station, or we interacting with the network. But as you can see with the PC5 communication, right, there is no, we are talking directly to the vehicle. There is no network in between, or how do I say, there is no base station in between, right? So this is the place wherein we can drastically reduce the latency when a vehicle is communicating with another vehicle. So we call this again PC5 or LTE side link communication. Then we have the uplink and downlink communication or data transfer that happens between a vehicle and with that of the network, right? We call this the UU communication. And how we are now simulating this in a lab environment or for a test environment. So the diagram on the right hand side explains just that. So you have your DUT which you are developing, which is shown in the vehicle image, right? We have noted it as DUT. Let me try and see if I can put a pointer on the screen. Yeah. So the DUT, this DUT that I'm showing here, the car is basically the CV2X module or system that you are developing. And the second vehicle or the third vehicle, the other vehicles on the road is simulated by a reference module which supports PC5 communication, right? This is how we try to simulate the other vehicles on the road coming from different directions. And then to simulate the network for UU communication, we have our network simulator MD8475B. Now, if you are interested in solely verifying or validating the PC5 communication, the ITS messages, the CV2X related scenarios, the network simulator is really not required. Just the reference module is sufficient. And if at all you do have other, in addition to CV2X, if you have tests related to UU communication or telematics or basically server communication, that's where a network simulator would be required, otherwise not. So you have seen this diagram when Sahu was presenting, right? So typically there are multiple ways you can go about with testing your CV2X product or module. So one, you have your physical layer verification or validation, right? So for which you would need an RF call box or an RF measurement analyzer. And then the other typical, another main testing that you would have to do is where you are simulating various road scenarios, and you are checking if all the messages, ITS messages that is being sent from one vehicle to the other vehicle are all in line with the specifications or not. So we call this like a system level testing or an application level testing. So this is so typically what is being done by a CV2X, the one who is developing a CV2X system, right? They go with an application level test because this is where your major the software is being developed, the use cases are being developed and tested to see if the messages exchanged is being well exchanged to the other vehicle or not. So how does the test a block diagram, or how does the test solution look like? So you on the right hand side, the vehicle, or what we say is a duty, this is the one which you are designing. The other vehicle is being simulated by a reference module. We would have a GNSS simulator to simulate different coordinates, or at least give a simulate a situation wherein your vehicles are in a different are how do you say they are going in different directions, or they are a little further from each other and then moving towards each other. So this is kind of simulated using a GNSS simulator. And then we have a software tool which controls the entire test setup, and you can create various road condition or vehicle scenarios, and then test how the DUT and the reference module are communicating to each other, and if a warning is being established at the DUT side or not. Right. So I do have some small screenshots at the bottom, but they're not very visible. But we do have a dedicated demo video on YouTube, maybe which we can share it to you at a later point. So what kind of specifications are we following? So we follow PC5 communications. We are following the 3GPP standard. And for the use case generation, we are following ETSI and the ITS standards, right? Especially the regional ITS standards we are following. So you can see there are around 14 test cases on the screen. These are already readily available and can be simulated to test your CV2X system or module. And again, you are not, for a developer, you are not limited to these 14 scenarios. You can always create your custom scenarios and test your CV2X module further. But these are the standard test cases that are being defined by ETSI and the regional ITS specs. So the same thing has been also readily available on our solution. So you can see popular scenarios like your forward collision warning, blind spot warnings, emergency brakes, left turn assist are all available readily. So you would have seen from Sahu's presentation, there are some countries that are very active in the CV2X development and deployments. So So the solution that even we have designed is keeping that in mind. We have the regional standard supported, that is your US standard, the China standard, as well as the European standard. So we have all these spec available with us, and you can test your CV2X message layer or ITS stack against these specs, right? So this is how, if at all you are planning to, you are genuinely interested in having such a setup, you would need multiple hardware and software components and accessories to build that kind. It's very simple. Like I mentioned earlier, you would need a GNSS simulator, the reference module, and a software control software. So now this is so far whatever we have spoken was predominantly for the application level testing, wherein you're defining those use cases, uh, road conditions, traffic conditions, and then seeing if the warning is being established or not. Now, for those who wants to do testing related to the physical layer alone and not application layer, right? So we have a product by named 8870. So over here, this is designed specifically for physical layer or modem level testing, wherein you are checking the transmitter and receiver parameters, the modulation analysis, if everything is as per the 3GPP standards or not. This particular instrument supports both your .11p standard as well as the PC5 CV2X standard, right? You can use this at the R&D for doing your physical layer validation, and it can also be used at end of line or production line testing, wherein you want to test multiple such CV2X modules at production lines, and you want to do a pass or fail check. Um, so, so that way you can maintain consistency at R&D as well as production lines. So this is just an example of all the use cases or the measurement items that is defined in 3GPP and that we support on the solution for physical layer validation and at R&D or be it in manufacturing. So this gives a summary of what we have for CV2X testing. So if any of you are working actively on CV2X related projects and are interested to either a physical layer validation or a application level validation, and you're looking out for a economical solution and not a complex solution, something that would be very feasible to start with something small before you go with something complex, then do give us, do try and reach us out, and we'll be able to give you some more details, maybe even give you a demo or an evaluation, so that you can see for yourself before you think of the next step. That's all from my presentation.